you very much for Professor Zhang, who cannot be here today, for connecting me for this great opportunities. This is actually my first time to the Health Sciences campus, and I haven't been here before. It looks great. Let's get started. I have 1 hour and 30 minutes. I will try to make it as productive, as relatable, and as useful as possible. And the topic is called Gentle Introduction to Modern Agentic Workspace. Subtitle is Prompt, Context, and Autonomy. So let's get started. The goal for the next 100 minutes, maybe 90 minutes. So I will first try to introduce you to the landscape of the current AI, bubble, if you prefer to call it, or trend, the future, if you're more optimistic about that. So that's going to take about 30 minutes. And then we are going to have some hands-on experiences. I put a star sign here. I will explain why. We're going to practice with modern AI tools. And then we will try to develop some instinct, also rule of thumbs about how to work together with AI. It's going to take another 30 minutes. Well, I just updated the slides, so it should be 90 minutes because the earlier one is 100, but that's okay. So after I did some experiments, I realized that we won't be able to actually reproduce everything as I planned. The main reason is that it's going to take some time for AI to think, to plan. So that's why I decided to open source all the materials I used for today's presentation. The link came sent earlier. That's the GitHub repo for all the activities, including the slides I'm using here, under the prompt and the content that is used to create the slides. So everything is a result of the collaboration between me and AI. So yeah, I will try to make today's content as relatable, as practical as possible. If you have any questions, I probably won't be able to monitor the chat. So Kim, if you can, if you have some questions, you think I need to stop and respond, then we can stop anytime. Okay, good. So a little bit about me, very quickly. I graduated from USC in 2019. I had a physics and the EE major. I was a physics CNC major. After that, I went to ISI, the research institute in Marina del Rey, as a researcher to work on knowledge graph. It's a subject domain of machine learning. Then I went to the industry, work as an engineer, data scientist.
Okay, if we just make that smaller, and then we can see the slide.
Oh, yes. Okay, no, oops, even bigger. Okay, do this. And
just trying to get the people. There you go.
Even this, yeah. Thank you. Yeah. So after that, I authored a few books. Now, when AI came out, nobody bought books anymore. So those books were obsolete, mostly about statistics, data analysis, and a little bit Python programming language. After that, I went to Vancouver, Canada, become a math instructor. So I created my own math curriculums now. They are a mixture of mathematics, physics, game design, and of course, computer science and AI. The adoption is evolving. Most people don't realize everything is going to change with the emergence of AI. But I already get some hardcore supporters who really appreciate the new curriculum. And for you, I would say anyone curious about AI's rapid evolution, especially students and researchers who are seeking 3 to 100 times productivity gains. I put 3 here because it's a reasonable number. 100 means from my own personal experience, I can say with AI, I have done something that I probably won't be able to do in a century. Because I don't have the time to actually learn. I want to put infinite here, but just to use 100 as an approximation for infinity here, right? It sounds more reasonable. Yeah, but the fact is, it's really infinite, right? I have so much other stuff on my plate. I cannot be a front-end developer. I cannot, work on things it's going to take months to learn. But now, with the proper prompting and the ways of working with AI, I'm able to achieve that. All right. So let's go to our first section, the evolution of AI stuff. I cannot find a better word for the, those collection of terminologies and the technologies and the ecosystems. So I think the common question we're trying to answer is what exactly are blah, 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 like all those kind of stuff. LLMs, prompts, context, MCP, skills, agents. So every day, like you go to Twitter, you will find new stuff. But if you put on an evolution chain, you will see the connections here. So I'm going to, we're going to start from the beginning of the chain and try to figure out everything. And along the way, we are going to have some activities that are, blending. Okay. Different organizations people have different definitions. I'm going to pick the intersection side. So everybody agrees, okay, for example, an agent must have such capacities, for example. All right. So we're beginning from language models to so-called large language models. About 2017, when I was at USC, I did a project that's just building a next word prediction. It's called 2-gram models, like using R, actually, Shiny and R, to build such a model. And now look back, that's more like a Stone Age model, right? Like language models. So the breakthrough happens in 2017, the Transformer paper, and it enables massive parallelization. But of course, both the architecture software side as well as the hardware side later. And it also enables the message to pass through like the computation, neural network computation that usually lost before. So Transformer was really the big thing then. Then you have the explosion of the parameter numbers, starting from millions, then billions or trillions of numbers. And the real iPhone moment, I believe, for language model is the 2022, November 30th. Sam Altman said, okay, today we launch ChatGPT. Before that, large language models were already a thing. Like for me, I already see some, they can do this, but they're more from like a small group of people, like those researchers or small community. But suddenly it's available to many, many people, to the whole world. And AI goes mainstream. People realize maybe it's not just a sophisticated sentence completer. Maybe it can do something more than that. And yes, still many people believe it's just a sophisticated sentence completer. It's just all bubbles. I actually have the tweet right here. Like you can see, maybe he probably tweeted on his phone. I don't know, but it changes everything. This thing. Okay. So let's start from the simplest use case, like at the very a young age of LM. It's a sophisticated sentence completer with no built-in memory between turns. For example, if I ask, what's the next number after 4? It's going to say 5, right? As a completed sentence. Then I ask, what's next? It's going to say, hey, I don't know what you mean by next, because the memories were cleared. There is no information passing through or transferred from the first turn of conversation to the next round, right? At this stage, the model may be huge, but it's really just a sentence completer. Well, the sentence itself may be as short as one, token. It can be as large as a sentence, but no, it's just a completer. Each turn is independent. So what we call this a prompt. It's basically an input. Well, in this case, it's just a sentence, a human sentence, but with the ability of tokenizing everything. We don't have the time to dive deep into that. Images, like voice, sound messages, all those things can be tokenized. Basically, they become 0 and 1 and bytes, right? And this basically is also a 0, 1 if you use some certain kind of encoding. Okay, then what's next is that people realize if you want to achieve continuity, you have to introduce the idea of context. The context is really like the human conversation. If someone joined the conversation, well, we usually, for example, Kim and I were talking about something and John joins, I will stop and explain to John, hey, what we were talking, so you can join. That's the idea of context. So the prompt 1, and you get the answer. You combine those things together with your new prompt, and you bundle them together. This becomes your new prompt, and you get a new answer, and back and forth, right? So clearly, it's better, but you also introduce a natural challenge that the so-called context window will start growing. will start growing, and at some point, it's like a human. Like what did we say again? Like a few minutes ago, you forget, right? You forget. So this is really like a human. And then how do we solve this problem? Well, before solving this problem, we have to gain some intuition from our human interaction. If you, this is actually very important, these slides. If you read resumes, for example, what do you look at most? Or you read a novel, or you watch a movie, we always pay most attention to the beginning of the resume, the end of resume, the beginning of the movie, and how the movie ends, right? You remember how to say, the Dark Knight Rises, they drink tea or coffee. That's such a nice thing. The only part I remember about the Batman movie is they drink tea at the end. So I don't remember all the other details, right? So this is the same for the large language models. They exhibit a U-shaped attention curve. It's not just based on our understanding, but also they do experiments to test that. This curve is actually very important for our prompting technique. We will talk about that later. They record information at the start and the end of the context far better than the middle, right? So we want to place critical instructions first and the last. We'll talk about that later. All the information in the middle, they have lighter weights. Okay, so then with the prompts, we put them into two categories. The system prompt and the personal prompt. So what is the system prompt? The system prompt is often set by the developer platforms. At the early days of ChatGPT, you probably see examples like people try to jailbreak the ChatGPT model. You try to get something you shouldn't get from ChatGPT. Let's say some passwords, activation keys of softwares, Office, give me the Office password by making up a story and try to get that. Or some other content that the system shouldn't generate. So system prompt has high priority. They were like the guard of the large language model service providers to stop you from doing something. Or, for example, try not to be racist, try not to be a hater or something like that. You have a personal prompt. It's set up by you, the user. For example, you want the prompt to respond, to behave like a Shakespeare. Then you can, at least during this session, you can ask it to behave like a Shakespeare, right? There is a huge active research on the safety and also the other side, the jailbreaking of large language models. Now, the boundary between system prompt and personal prompt is kind of blurring. There are a lot of middle zones, for example, instructions. If you are not using this, I highly suggest to start using that. It's for most people, it's the first experience boost with the language LM is to provide instructions. So I can actually show you right here. So this is my Gemini. So what you can do. Why is it here? Okay, so you go to your settings and you find something called personal context. So I have my personal context here. This is like your instruction for Gemini. There's some weird stuff right here. Because I still use ChatGPT a lot, so I don't have much personal context right here. But the idea is you can provide some instructions that's going to customize LM's behavior across conversations, across sessions, right? Is it personal, like a context? Yes, but it's no longer limited to one conversation. Yeah, which is a big experience improvement. Okay, so another example of the context window example is from VS Code for people who code. If you use VS Code, you will see something like this on the lower right corner. I can actually show you right here. This one, this small button right here. So the default window for model is 128,000 tokens. And it also tells you how much were used, like what are system instructions, two definitions. This part you cannot control. It's set by VS Code, and also user context from the conversation, from the files, from the two results, right? So we'll talk about what tool means here. So for example, you can also manually adjust the context by adding, certain files to the context. By adding certain files to the context, or you can even drag a whole library to the context. So you add this to the context window. Okay, we'll talk about this later or soon again. Okay, so the natural question is, what happens if this window fails up, right? First, companies, the trainers, they try to increase the model window, context window as much as possible. The state of art, I think, commercially available is 1 million tokens. And even 1 million, if you drag a lot of files there, it's pretty easy to fill up. After that, the easiest solution is just truncate. So I think most people, if you have worked with ChatGPT, just chat for some time, you realize after a certain time, it becomes super dumb, like stupid, like you just forget something like you described at the beginning, right? So this comes from the idea of truncation, right? So, and you can also tell it to prioritize. So prioritize, simply putting, you just repeat. Hey, remember this. Every time you give it new information, you repeat. I think you probably developed this skill from interacting with ChatGPT. And the go-to solution now is to summarize. So you try to condense. Now in VS Code, it automatically summarizes the current Windows content and bring it the smaller condensed version to the next round. I call it the Fibonacci's context. So have you heard about Fibonacci soup? Like you take today's soup, the leftover, you bring to the next tomorrow, and after you sell them out, you bring the leftover to the next. So you keep doing that. This is like a Fibonacci's context. Yeah. Okay. So all right. So now we have a prompt, system prompt, and the context. System prompt, personal prompt, context. What about memory? What's the difference between context and memory? So context, oh, by the way, different people have different definitions. This is the part that everybody agrees on, is a content background that is available, background content available for the model to see right now. The model is able to see right now. It's basically the background information that is active right now. Well, what memory is more like a persistent layer across sessions. Like you may have different talks, conversations with the model on different laptops at different times, but the memory, they often persist. So they are stored somewhere, right? For example, they can store in a vector database, some key value stores, it's like a dictionary, and etc. And those are selectively retrieved when the contexts were relevant. So give you an example, like a human interaction. So for example, you have your high school classmate you haven't seen for a lot of time, right? You had a lot of interaction with the person, but you haven't seen the person for a long time. And suddenly the day you see him and you try to retrieve some memory about that, then decide your attitude toward that person. Should I hate him? Should I like him? So, right, those are about the memories, right? So they will persist. They are not active, but you can retrieve them to when the contexts were relevant. Okay, and the context, when they are persist, they can become memories, like a dynamic process. Okay, so here we have activity 1. So at this moment, we already know enough knowledge, enough content to start our activity 1. So actually I have a slide for the activity 1 right here. Okay, so it's a Taming Messy Research repo. So for folks who already see our repo, the activity 1, there is a folder called activities. And the activity 1 content, they are all here. You have the slides and you also have the refactor report. We won't be able to do it live because it's going to take the air to sync. It's going to sync quite a long time to figure that out. But we can go over the ideas and also the philosophy parts here together. Okay, so the idea is context is everything. So I set up a scenario. Jenny is a graduate student in Dr. Chen's lab. There's the Dr. Chen here, whose student is Jenny, I don't know. over 9 months, she built an RNA sequence analysis pipeline, 37 files, 3 batches of data, 2 programming languages, R and Python, and 0 documentation, which sounds very familiar to me because I used to work on computational physics, and this is very relatable, right? You have different batches, CSVs, you have Python R shells, you have hard-coded passes, all those kind of things. There's only one line readme I can show you right here. For example, I have the MathLab version. You can see the files, right? Clean data, compare Smith, etc. V2 batches. I try to make it more realistic, more possible. Like it just no, go do that. And you have the to-do list. You have README, script and data for paper, blah, blah. All right. So we are going to ask AI to clean this mess for us. All right. So why does context, in this case, this information matter for AI? You treat AI as infinitely patient, infinitely fast, like a guy with 200 PhDs, like a guy that's behind who is 20 people, like a highly productive engineering team, but it starts with 0 background. So without context, it will try to guess which results file is canonical, like what you desired. It's going to miss the sorry total across comments. It's probably going to break hard-coded passes. Of course, it's going to do the so-called the best guess based on the data that this model is trained. But if you really want to get what you want, you have to supply the right context to the agent so the agent can help. All right. So this makes the first prompt critically important. The first prompt critically important. Remember this slides we see earlier here? So if you are having a conversation, what will be the beginning prompt? The beginning prompt is essentially the first 1 or 2 prompts. And what is the last one? The last one is just the last conversation you had. The thing you want, like that to be changed immediately, for example. So you want your first prompt to be of extremely high quality. So when I create like a nice content, sometimes my prompt are like 4,000 characters. It's like basically writing an essay. It's not easy. It's really not easy because I realize if I don't do that, this conversation is going to, how to say, degenerate, right? At some point, I would say, I should just start a new conversation. Some of you probably already have this experience. I should just start a new conversation. This is not beyond safe. Like I cannot save this conversation to get it to work, right? Even I try to add more, I could do this, to fix this, fix that. At some point, I have to discard it, right? So you want to focus most of the time on working on the first prompt. Okay, so how do you get to the first prompt? You need to figure out in which quadrant you are in. I cannot find who was the person who come up with this, the first, but you can basically divide the situation into one of the 4 categories. The first category is that the context, and the agent also knows. This usually happens after you have certain amount of conversation or you have detailed documentation. For example, if you are working on a new software and that new software happens to have a website that contains detailed documentation, just drag that URL to the agent and the agent is going to read that. How it is going to read that, we'll talk about that later. So basically the agent knows more better than you because it's going to read all the documentation, but you also know because maybe you have used that software for quite some time, right? So in this case, your role will be the reviewer, right? You are going to, judge the final results, right? And there is a part that agent doesn't know, and you know, and there's no easy way for agent to quickly, for the AI, I would say call AI now, we'll talk about the concept of agent later. AI, has to be you to provide the context. Then you have this tricky part. This tricky part is that you don't know. You don't know the context. And you know what you want, but you don't know the context. Agent knows. But for example, agent, let's say you want to build as a researcher, you don't have like a software development experience. You want to build internal in-house tool that to help you achieve some goal. You don't know the industry experience. You don't know the industry how to say best practices, and you don't know any front end knowledge, and you don't know how strong the server will be. So and the real issue is that you don't know that you don't know that. Like you don't know, you don't know. So in this part, you have to be the student. Instead of asking how, instead of asking like giving instructions based on your limited knowledge, you should ask questions like meta level. Like, for example, here's a question. I'll give you a quick example right here. What would be the success criteria for organizing this repository? So instead of defining your own success criteria, you need to ask a question like, hey, what do you think like would be the best criteria for me to choose from? Okay, so that's a student zone. Then you have the part that you just research together. Both of you don't know, just have a conversation to get the big picture. So you can either evolve into this region, then last at the end, you want to finish your work in the reviewer as well. Okay. So for Jenny's repo, we are mostly a teacher because you are Jenny, like you wrote those files. You understand the project, the agent needs you to explain it. After that, you can shift into reviewer mode, and occasionally you probably need to dip into student mode. For example, you don't know how to do testing, right? This is from my industry experience, I think testing is probably the biggest gap there. Like you want to write test, like you don't want to just work. You want to write test, so it's reproducible and it's easy to maintain. Okay, so my suggested workflow is to state your intent rather than state your action. It's like a shift lanes on highway. The turning light means I'm going to shift. It's an intention. It's not an indicator of action. You describe the goals precisely, completely. You want to include all the assumptions and constraints. You want to let the agent analyze first, then you shift roles between student and teacher. At the end, you finish the job as a reviewer. So I'm giving you a quick, short, this is really short prompt in my opinion right now. So this prompt, so starting from here, this is what you want. This is the intention. This is the intention. I did not say anything about what the final result will look like. I didn't say how you want to do it. I just want to say, hey, use very vague words like analyze, identify, issue, then say what issues, and draft a recognition plan. And here, this is about the background, the context. Some of you may think they are not necessary, like who you are, like the student, you are a graduate student, you're written by a single student, but those information are important for LM. So they are going to, derive some implications. Okay, so what your tech level is, like should I introduce more fancy, how do I communicate with you, with my master, okay? They ask the question, the user, etc. So they are useful, and the batch information will also be useful as well. Just context and the intent. Okay, so this is we showed this earlier. Hey, be the student who ask meta questions, right? So ask what will be the industry standard? What would you think the success criteria is? And you add your information during the conversation. My plan was trying to do this live, but it's going to take too much time. But I have everything here. You can see the refactor report right here. I'm going to show this one as well later. Okay. And okay, those are the tests against those criteria. As a researcher, you learn from this, okay, for example, how to do a so-called smoke testing, how to check the spot check results, how to analyze the boundary cases, etc. And at the end of the day, you will be the final reviewer. You ensure the agent, the AI has all the context, that it's not going to make mistakes because it doesn't know the context. It will only make mistake because it's not able to. Right? It's just beyond its intelligent limit. Okay, so that's the mission. I realize 10 minutes is not possible, but I want to show people the refactor report. You can also see this. Okay, preview. Wait. Oh yeah, okay, it's just take too much time to render. Okay, so this is a refactor report. So you can either request to create a refactoring report in your request, in your prompt. Well, before that, the key asks the meta question. Ask it, what will be a good criteria for a refactoring report? Then you ask, then you use the response, those, okay, for example, it should include the executive summary, it should include, the autonomy of the original repository, and you use that information to feed back to the agent, to the AI, to solve those issues for you. You can see, like the example I produced was quite impressive, I would say, like it reduce the duplication scripts, remove the hard-coded absolute passes, etc. And it also give you a one-to-one mapping for directory structure, of course. Also one-to-one mapping. What is the, for example, massive files, where they are right now, and what do they do? So, for example, the two R languages, and the file that were refactored with a one-to-one mapping here, like what do they do, and what improvement, what they made, etc., things like that. Okay, and you have the pipeline outputs. These are the expected results. So make sure like your output from original files and new files, they kind of agree with test files, right? So those are results. Okay, yeah. So yeah, we already covered those part a little bit. Okay, so that's our activity number 1. And they're all here. Okay, so far, we are only using the intrinsic capacity or ability of the large language models. We are not using any external tools. Although I already mentioned the idea, like you can basically support URL of the full, new software for AI agents to read the documents, to inject into its context. But the real magic happens when the LLM model can retrieve external informations. For example, if the model was trained using the data that is truncated before October 2025, for example, then the model will not be able to know, let's say, the Winter Olympics, the medal information, has no ability to do that. Okay, so early days, still now, people were introducing the idea of called the trivial augmented generations. This is a scary name. Like, what does it mean? RAG, retrieval augmented segmentations. But it's actually very simple. So first, let's say user asks a query, what is X? So for example, what is the number of gold medals of US in the Winter Olympics? So it first goes to a so-called retriever. So this retriever is not going to, ask LM directly. It's going to use some kind of embedding technique to find the most semantically relevant results from external sources. In this case, US, Winter Olympics, gold medals. And if this data is in some kind of database, let's call it knowledge base, well, it can be PDFs, can be of databases, can be of web, can be of APIs. And you first retrieve the most semantically relevant information. You put them together, right? You put them together with your original query. This is your new context, and you submit this new context to the LM. So now this LM will see your query and will see the information that the retriever retrieved from external knowledge database. Then it's going to use those combined information to generate the responses. You often supported by facts rather than some hallucinations. So suppose you are, let's say, like we have a company has some internal data, and there's internal data, there are facts, and you want your response to be supported by facts. So you want to build a layer on top of, in front of the LM to augment your context. So retrieval happens here, augmented happens here, generation happens here. It's basically a sequential pipeline. Okay, so that's RAG. That's RAG. So two main challenges of RAG. First, natural language understanding. If you have written like a SQL queries, like you do those kind of things, like a SQL query is very rigid. Like you write select blah from group by like a limit, etc. So they cannot be like as flexible as natural language. So you want to fix that. And also external communications. So if this is not from like a database, let's say it's from web, like you want to use a tool, maybe like let's call it search tools. So your LM can use that tools. You want to maybe get the tools and your LM closer in this case. How do you allow the LM to actually use those external tools? Those two challenges here. The first one is easier to solve. Just use embedding. So you probably see this classic examples, like if you embed human languages into a vector, like a high dimensional vector, maybe even thousands of dimensions, you basically can draw a vector from women to queen and man to king, maybe like Beijing to China and the US, Washington, D.C. to USA, and you can draw some similarities here, right? So if I ask Winter Olympics, US gold medal, then in the database, I can embed my results. I can also embed my query. If they align a lot, define some similarities, then I think the information about the US gold medal count in the database is the most relevant information, and I retrieve that. I put it together with my my original query. So I can use vector database to do that. So this is a solution to the first problem. So far, it works pretty well. In our activity 2, later people will find we are actually building a local vector database using the so-called ChromaDB. Right? We'll talk about that very soon. If you are, you want to, read ahead, you can just start reading activity 2. If this part is kind of not new to you. Okay, that's perfectly fine. Okay, so how about the second question? The second question, how do we enable large language models to gain, to invoke other tools? This is where we have the so-called function calling, right? So we gradually introduce the terminologies as we build softwares and the frameworks around the LM. So for example, user says, I want to book a flight. How many people still remember, like there used to be a thing called GPT. Like ChatGPT introduced something called GPT. Like you can, it's like a small, icons. You can drag and perform certain things, like I think Shopify developed GPT, Booking developed GPT, Expedia developed GPT. So when you use those tools, at the core is still LLM. The LLM is going to understand your intent. You say book a flight to like Vancouver, for example, next Sunday, etc. So LLM is going to structure your input as a JSON file. A JSON file is just a file format that looks like this. The structured function call. So we have a function that's called book a flight. This is a keyword in this case because it has to be provided by the service providers. For example, Booking.com. Booking.com work with ChatGPT said, hi, I provide a functionality that allows your users to book a flight. However, I request those arguments such that in order for me to, for our side to actually book the flight. So then when the user says something like that, you structure that and you send us information to us, and we're going to do the booking and send you a response to see, hey, whether it's successful or not. Okay, so this works, but there are some issues for that. For example, this Booking.com, as example, have to work with different large language model providers to register to say, okay, I have this functionality. And this format is very rigid, and it's strongly coupled with the large language models. The service and the model, they are strongly coupled, right? The translation happens inside the large language model here. Okay, as the software, engineering, like a philosophy said, if something doesn't work, you can add a layer of abstract on top of that. You can make them loosely coupled in this case. So we have the so-called MCP. So you probably heard about that. So MCP is called Model Context Protocol. So the idea is like, yeah, function calling works, but what if we introduce a universal open standard for connecting LMs to external tools and data sources? For example, you no longer need to register your services. The LM can basically call a client and set list all the available services. So I have an example right here. So nowadays, if you use VS Code and you search, you will see you actually have MCP server stores, MCP server stores. Now I installed 3 of them, and the fact that this Google Scholar MCP service is written like on this laptop is kind of crazy. So you can create your own MCP. Basically, you can create, because it's open standard, you can write a protocol, sorry, you can write a service that follows protocol that only does very specific things that you want your LM to be enchanted to do. So that's crazy. So you can have like a very strong, powerful internal tools. So we have GitHub like this one. So this GitHub MCP server allows me to perform like a review, pull requests, check actions, or those kind of things locally without going to the GitHub webpage. So that saves a lot of hassle because programmers, researchers, they want to stay on the same page. They want to, just look at the same screen, don't swap back and forth. The idea is like you have an MCP client, and this client will talk to different servers, and those servers may be written by GitHub, maybe by Slack, by email, by calendars, and they are performing the task on behalf of your client. No, your client means like the client that lives on your machine and sends back the results to you. Okay, so everything seems very nice so far. Everything seems so very nice. So we have a comparison right here and function calling, and you can say tight and rigid, and you have to announce yourself as a service. And MCP is just loosed. You can think of the MCP as like a USB plug. Like you have a camera, USB camera, you have the USB mouse, you have USB keyboard, and you can just hook in and get it working, right? You don't have to, add additional button as if you have a calculator, just keep adding stuff on that, which will make it harder and harder to maintain and more, how to say, heavy in that case. Okay, so we have activity 2. Activity 2, I created this activity 2 to try to simulate a scenario that researchers will face. So suppose I have some PDF, papers locally on my machine, and suppose like I also go to Google Scholar to maybe check some what's happening in the industry, but I also want to have some notes. What if I have one interface? I have one interface that I can simultaneously search what's in my local storage on my laptop, what happened on Google Scholar, and what did I write in my notebook. I can search those 3 things simultaneously. Before the AI, the idea is like you have to wait for the tutorial or other, like a reference management softwares to develop such tools for you. But let's try to create these things on our local machine. Like let's try to create something like a in-house, right? So I think I have this PDF ready actually, right here. Yeah. So I'm going to review this finder. Yeah. So this is activity 2. So again, we focus on the philosophy here. Again, so a quick review. We did some cleanup. Now we are going to create something. So we want to describe something that doesn't exist yet. The AI doesn't have, it's no longer going to clean something that already exists. You have to describe what you want. Well, here's the thing. You may not know the skills you need. For example, you probably don't know there are front-end, frameworks like React or Vue, those things you don't know. There are things you don't know. How do we navigate in this scenario? Okay, this is harder. You have to articulate what you want clearly enough that someone with zero knowledge can execute it. And that someone is the agent. We're already using the agent. But as you can see, The concept agent, I haven't touched that. We're going to touch that later. Okay, stay to the goal precisely. What you need, not how you build it. Okay, I need an application that can simultaneously search Google Scholar and my local PDF files, along with any notes I have associated with them. I should be able to download the paper from Google Scholar directly in this application. I should be able to semantically search the full text of my saved papers. Again, nothing about how, just what I want. And this is the what, okay? I didn't mention any framework. And now agent knows the destination. It will figure out the route, okay? And you also need to state your restrictions. So you make it maintainable. In the long run, if you keep adding more and more functionalities, it's called AI slop. You probably heard that. So it's going to be chaotic code that somehow works, but it's not going to be maintainable. So you want to say, okay, I'm a graduate researcher in biology. I have basic Python experience, but no web development backgrounds. I have never set up a database. That's perfectly fine. You're not doing an interview. You can comfortably tell AI, I have never set up a database or server. My machine runs blah, blah, blah. You can, if you don't know this, you can just say, please Python. Please explain every step before execute and check that if I understand before moving forward, right? So which zone are we in? We're in the explorer zone right now, right? So you're trying to, poach around and figure out what you are comfortable with. So this will change everything about how the agent responds. The agent will not do some heavy liftings, building fancy website URLs, like UI interfaces. It's just going to, give you like a minimum MVP. And as a researcher, I don't believe people, care about the beautiness of the application at this moment so far. Okay, so ask for a plan before any code. So ask AI to propose options first. Now you are more like a student. Hey, please enlighten me and show me which route should we go. Give me 3 possible approaches to build this. For each approach, explain the trade-offs in plain language. Let me choose which direction to go. Okay, give you visibility, give you agency, give you understanding. So the AI may give you 3 results. Again, this was a result from my earlier test. If you do it now, it may be different because based on a model, based on the information you provided. So it's going to say, okay, so maybe I can provide all-in-one Python script. It may be written in Flask. Very simple, like they search locally, it's in terminal. Trade-off, simple but limited. Option B is going to build a backend, maybe again use Flask or Fast API, those kind of things. So option C, you can basically, for example, if AI tells you, I'm going to use Fast API, you can ask, hey, what is Fast API? And what's the trade-off? Is it completely, maintainable on this machine? So I don't need to go to the code details, etc. And you pick, you control everything. All right. So ask AI, what is down, like a defined down, like what should we check to know it's working correctly? If something doesn't work, then you can fall back to ask AI to fix that. Okay, so here is an example, a simple, like a full opening prompt. You need to put everything here. Like this is not complete. This is what we have listed earlier. You need to put everything here together as the opening prompt. So that's why I say like a 4,000 or even longer prompt, initial opening prompt is actually quite common. It's actually quite common. Yeah, because it's going to determine the fate of this conversation, of this project, essentially. Okay, so I'm not going to go into details like about the other stuff, but let me give you a demo. So this is a real thing, like I just created. All right, so let me make sure it's working. So this is what AI created. AI made some go-to defaults. For example, it's going to save the PDF files locally, which is okay. For example, I have a library here. You can see this is from today, this is from yesterday, and PDF files, and then AI just downloaded automatically. So I have 4 local files right here. I have 4 local files right here. Okay, and I can start searching. I say, what should I search? I should search like let's say Walter Bowling. I have no idea. Okay, let's see. Let's search. So first, it's going to search both locally and give you a similarity. So somehow it thinks the Ubuntu operating system has a similarity of 1.7% and some lower. This one has a polar bear. Well, I should probably think polar bear have a higher like a correlation, but that doesn't really matter. You can ask AI what similarity algorithm did you use and which text are you used to build the similarity. You can always keep building on top of that. But also at the same time, you are searching Google Scholar. So they are all in the same interface. And for example, if they are in archive, you can just save it to your library directly. Yeah, so 191 characters was saved in a vector database because when you specify you want a semantic search, AI will automatically figure out, hey, we are going to do to save it in a vector database. So now you can see local library. I have 5 papers, and the fact that you are saved as a raw text means you can see them. Where is it? Library today. This is the one that was just saved, but the content was truncated. You can ask more explicitly, hey, let's introduce more, increase the content length, which is perfectly doable. Yeah. So as MVP, for me, like I will be happy with this MVP, and I can add note to it. The note will be also indexed and embedded into the vector database. Okay. And there's no existing tools in the market that does that, but you can build it yourself, and it only serves your purpose. It's like you have a personal software company that just help you to do that. Okay, so now we have the emergence of agents. Different people have different definitions of agents, and for me, by the way, all those images in these slides, they were AI generated, and they were generated as exactly as the idea like I described in the slides. For example, this particular slides, the emergence agents. Let me show you. This is maybe the funniest part of this slide. Okay, so they are created from MD file, from Markdown file. So let's go to the emergence of agents. So what I tell AI to do was this. Describe the concept agents and how it's different from traditional MMUs. Create SVG to illustrate the concept of agents. Agent is the big circle, enclosed LM as its core brain, surrounded by tools and external data sources, and the human interact with the agents. So this is a prompt. I ask LM to actually create the picture we see exactly here, but I put it into comment, so you don't see that. What you see is this SVG file, but how do I style this one? Did you notice? This is exactly USC color. I can easily make it UCLA color and replace this sigil right here. So I have some master level instruction on top. So I'm going to show you. You can use this technique to create your own slides very easily. See right here. Okay. So I have some guide, content generation guide, visual style guide, language style guide, multimedia style guide. This has become like a meta thing. Look at this visual style guide. I say prefer USC color. I grab those 2 colors from the USC website. So it's going to stick to those 2 colors exactly. I don't need to adjust any, RDB. Limit each page content to less than 8 rows of text. So that's why each row here, each slide, will never have more than 8 rows. For example, this one, 1, 2, 3, 4, 5, 6, 7, 8, exactly 8 rows. So I don't need to worry about overflowing at all. It's like creating PowerPoint, no overflowing. So to prepare for our audience, I said, prefer professional vocabulary, but avoid cliche and tech jargons unless no better choice is available. Right, so this is how I prepare to different audience. But how are the content generated? For example, okay, I'm exposing all my secrets right here. It's going to increase your productivity. Let's say this one, the key challenge in rock. I didn't write all those content myself. So if I search this thing, let's see how I created this slide. I have a meta like a prompt that basically says, you treat my comments as a as a starting point for the generation. So see here, see here, describe two main challenges in RAG. The natural language understanding and the solution is to use a vector database, and the communication between LLM external sources also show the solutions. So AI, the agent, read those two lines and generate its content, right? So we are collaborators, and I am the reviewer who tried to safeguard that the correctness of the content. And every page are like the same example. So basically for this prompt, I'm writing comments for each slide. And I drag this to the context and ask the AI to follow the meta guide, which is written right here. My prompt for generating the actual slides context needs to stay even after generation. Don't take my prompt literally. They are mostly used as a start point and bound you in a given direction. So that's the secret behind this slide. Okay. All right. So now we can go back to the agent side. So I think agent, it's like it's as a person, but its core is the LM. But there are so many stuff that is surrounding it to make it really useful. For example, it has to be able to manage memory. It has to be able to do some certain level of planning rather than give you a fast response. Also, it's able to invoke external tools, also manage information across sessions, and to make those sessions relevant, to make the memories relevant with the sessions active. And you interact with this agent. Okay. And there are three interfaces of agents. For example, command line interfaces. I have one open, which is right here. So I don't believe many people know or use this, is that you can actually use Gemini in a command line interface. They have the so-called Gemini CLI. So this is basically it's called TUI, Terminal User Interface. And Cloud Code is also a TUI as well. And you also have the IDE, VS Code, Cursor, let's say what's called anti-gravity. They're all IDEs. Then you have the more GUI side, like GUI. For example, the codecs, like ChatGPT released a codecs that can basically organize the files on your desktop. They are like a secretary that lives in your laptop at that stage. But I think the IDE and the boundary between the traditional IDE that is just for code is really blurred with the GUI, right? So because operating system like a Unix, well, everything is a file, right? Everything is a file. As long as there are files, you can manipulate a file and change the volume of your laptop. It can of a speaker. It can change the brightness of your screen. Well, is it still a text editor or it's essentially operating your laptop? There is really no clear boundary. You can say either way, right? You can say either way. But I think ultimately, in order to have an iPhone moment of the agent, I don't think command line interface is going to be the future. The future is definitely going to be something like somewhere here that allows you normal people, like non-tech people, to use the agent capacity. Okay. So here are some other terminologies, and they were the tools to build agent applications. For example, LangChain. Okay, LangChain. Was a big name like about 1.5 years ago or something. Still, people use that. You use Python or JavaScript, etc., to build agents. It has the highest level of flexibility, but you have to be a developer in order to do that. And then people think, okay, let's do the low code or no code version. You have N8N. That basically it's like a Lego systems. You have different blocks. This block read PDF, that block do image recognition. Then that block send information to, so for example, DeepSeek, then get response, etc. So you can basically drag blocks and build your application. They both exist before AI, but now they are like enchanted by AI. They somewhere live in between. Now we have the so-called skills. So you may hear skills, for example, cloud skills and also open cloud, etc. But this terminology is invented by cloud, but the idea is really not restricted to cloud-specific product. For example, if you use anti-gravity, you can create something called a workflow, which is right here, for example. I can create something called a workflow here. Don't tell me you change it again. Wait. I'm pretty sure it was here, unless I need to open a non-PDF file. Not this one, not you. Well, this involves really quick. I cannot find how to create a workflow in this case, but you can see it here. I have rules, but I can also have something called workflows here. So I can invoke that workflow to basically conduct a series of tasks. So back to this scale thing. So let me see an example. Let's see an example of the scale. So this is an official scale. It's essentially a single markdown file provided by Sorbet. So here it is. This is rendered by GitHub. Okay, this is rendered by GitHub. You want to see the raw version? You can click the raw. Now it's become pure text. And a scale has some certain fields. For example, trigger. How and under what condition should I invoke this scale? Say, use this scale anytime a spreadsheet file is the primary input or output. Okay, to reduce the instability of the LM's behavior, you introduce some conditions that provide additional context or ways of doing things into the context, so the AI can, so the agent knows which, for example, documentation, which approaches, which standard, which rules should I refer to. For example, this is the requirement for the outputs. Every time the user is using working with Excel, you should ensure, okay, my fonts will be professional. Like don't use bizarre fonts, and make sure there will be no zero formula errors, right? So you don't have to state this, every time you work with Excel. Also preserving existing templates, etc., and also coding standards. And if there are places that you have to read the data, ask AI explicitly to use pandas. And if there are good ways and preferred ways and rejected ways of doing, certain calculation values, hey, use this using Excel formula rather than hard coding that, right? So it's essentially you're training an intern. The intern just got onboarded, super smart, super fast, like very patient, and you want to provide this skill. It's like installed on this person, on this agent. Okay, so here we actually, where is right here, preview. Yeah, so here we have some key sectors, key sections of the skill. You have the trigger, you have two selection, you have the formula rules that you want to enforce. You want to have a verification that you ensure the rules were actually followed, and you also want to have some style guide. This is 290 lines of markdown. There's no Python glue code, just examples for it to learn. The actual code that does the work will be generated on the fly. And there's no API wiring at all, just like the agent does the work. Okay, so advantage of scales. Scale, modular, composable. The idea you install a scale is just moving this file into the so-called skills folder and allows the IDE or the GUI application to discover that. Like I learned this skill basically means I have this file right here in my file directory. And the most amazing thing is that you can have a skill to write other skills. That's possible. You can have a skill to write other skills. It's basically you have a high-level engineer that is able to train other engineers to do stuff rather than let the engineers do all the stuff itself, although the engineer is already very powerful and strong. Okay, and also very highly portable. This is really reminds me like a similarity. I don't believe whether those people think about that. So I think the idea that everything here is possible, like the skill is possible, really comes from the fact, the design of the Unix philosophy. Like everything is a file. You work with hard disk, you work with network socket. They're all files. They're all files. So we treat this non-trivial abilities like a web search, like doing calendar stuff. And at the end of the day, you can basically, write down a detailed description and you put LM in between and let LM do the hard lifting, do the understanding, do the assembling of the tools on the fly. And we as humans, we can just talk to them, talk to the LM as an interface to interact with the physical world or anything else. Like everything is just a text file. Everything is no longer like a computer system, everything. It's more like the physical world. Everything is a text file, which is kind of scary in my opinion. But also get excited, like, yeah, I can just write things to, to hijack your laptop, to do crazy stuff. I just read the detailed scripts, detailed text file. Okay, so finally, OpenClaw. Like we reached to the stage, like we talked about the most popular star in the past few weeks. What's the big deal? Well, it's actually built on top of everything we discussed so far, right? But it has some like particular advantages that make it stand out. First, it's your hardware. It actually runs on your Mac, your Windows, or Linux. Your data stays private. I should put a star sign here. Means like unless some data will be sent to the large language model providers, but your data, they're actually physical files, not physical files, actual files. Like you can edit, you can move around. So that's really, really good. And also because it runs, for example, your Mac, it can send a message for you. It can take screenshots. It can access to your microphone. It can do all kinds of stuff that ChatGPT, Chrome tab that is not able to do. Also, this is more like a bonus. It can be hooked to WhatsApp, Telegram, Discord, which is making it very fancy. So people easy to, and people get excited about the idea. You can just send a message to WhatsApp to write an application, which is very cool. Also, persistent memory. So it has a .memory folder in your user directory. It remembers you across sections. So all the small details you said, for example, go to this directory and fetch my passport photo and send to me. You can do that. I see people do that. Like when you are traveling outside, you don't have your passport photo. You can ask your OpenClaw to run on your local laptop at home to find the passport photo on your laptop and send to you. That's perfectly fine. I mean, if you trust the but the idea is like next time you do that, this memory, the memory where your passport photo is persist, and you can alter the OpenClaw memory because they're just a raw text file. You can just do that, and also it has skill systems. It's like a building RPG game, like a character. You can just install skills onto your OpenClaw. Just train it. Of course, full system access can do a lot of things. I have OpenClaw client installed right here, but the gateway collapsed, and I usually don't use it on this laptop. This is just the client. I'll just show you the client because I want to separate them. I don't want this OpenClaw run on this working laptop. I have another laptop that runs it. Okay, so activity 3. This is really ambitious. I highly encourage people to try that. If you have a group meeting, maybe like 2 hours later, and you can basically send a message to OpenClaw, and it's going to build the group meeting slides for you. Okay, so I have a multi-skill agent that I write right here. So let me show you activity 3. So you have a skill. This is the agent, like the top level skill. It will behave like a group meeting assistant. And this skill has 4 or 5, I can't remember clearly, has 4 sub-skills. One sub-skill is responsible for working with Google Calendar. It's going to send calendar invitation to all the group members. And there is one skill that is responsible for creating the slides, the meeting slides, just the way I created these slides we are doing for the presentation. There is another skill that reads the latest paper relevant to your field and summarize them. And the idea is exactly like our activity 2. So activity 3, activity 2, they're actually related. Okay. And then we have the to-do management to track the graduate students, how much did they do last week, so they can report and find those information. And those skills are correlated. For example, the meeting slides, let's see here, paper digest. It's going to consume the output of another skill, right? So your paper analysis skill will do the analysis first and generate a structured formatted output. And this meeting slides skill is going to take that and use that to generate the slide. And how about for example, the to-do? The to-do management skill will report who did what's the progress, and this slides from page 3 to page 4, it's going to read from that output and generate the slides that with that information. Okay, and you can see that's a group name, blah, blah, blah. Of course, when it runs, you need to provide this information. But if you use OpenClaw, once you provide it once, it's going to memorize that. So next time you don't have to. You can just send a message or even voice message, like prepare the slide, then it's going to do all this work. And no one is going to need to write the PowerPoints again. It's just automatic, which is really, really crazy in my opinion. Yeah. But I realize if this is a 4-hour workshop, all those things can be done like in real time, including this one. But if you are really keen, I highly suggest just go over those activities and try to apply the skills and the philosophies we learned today. And just try it yourself. It's for the last one. If you don't want to just you don't want to use OpenClaw things, you just want to get this done on a local machine, you don't need to set up OpenClaw. So activity 3 is independent of OpenClaw. You can just write those skills and provide additional information and get the system running, right? You probably can just just here, for example, just to tell it, hey, prepare the use this skill, use this workflow to prepare the meeting slides for our next week, which is going to take about 30 minutes, but it's perfectly doable. Yes, that's it. So it's 31 pages, and let's have some questions.
Thank you. There. I just added to the chat the GitHub website that has all of this information on it. I was prepared for today.
So to very quick summarization, I think if you have one takeaway is that the first prompt is the most important. It's so important that you should spend a lot of time on that. The second thing is I have 2 takeaways. Second takeaway, I highly suggest you to read through my slides.md file, this file. So this file shows exactly how I created these slides. Creating slides is going to be probably the most common scenario, like you're going to use AI. So these slides you don't need to open PowerPoints. They are and most of the time your research slides just papers, bulletin points, and so Markdown. And then I use MARP. Of course, I know this thing exists because I ask AI, what is one way to create beautiful slides without opening PowerPoint? And it suggests this tool for you. And I say, give me a minimal example, then I iterate on top of that. And here we are. So I use this tool to do that. Okay. So you can even copy this one and try to make your own style. For example, all those styles, why it's USC style, it says it's USC, right? You can easily make it UCLA or any other university, any other scenarios very easily. So that's number 2. So number 3, I would suggest you to go through those activities. Activity 3 is particularly challenging. You will need some like a tech, skills, for example, to hook it up with Google Calendar. if you want that part to work. But once it's set up, it's going to run smoothly ever since. Yeah. Okay. Okay.
Thank you.
I'm going to stop share and any questions?
So I have a question. So this is a very intriguing talk. I think I learned so much.
Oh, okay. Thank you. Thank you.
So I have a lighter question if I can ask you.
Sure.
So at the beginning of the talk, you mentioned that this AI thing is gonna increase 3 to infinity times of the productivity.
Yeah.
And I'm a PhD student in this department. I guess in general, our population worry about this increase in productivity will decrease the required labor of us going to the labor market. And I just want to see what are your thoughts on this. So after we graduate, right? Are there any perspectives we have to focus on our studies in order to confront this challenge of increasing productivity, which is a good thing for society, but not very good for us as graduate students. If that's a
I'm a bad responder to this question because
Okay.
I dropped out my PhD. So I went to USC as a PhD student, but I dropped out and I took 2 master's degrees and left and started working. So you are better than me. Like you're going through this. So you're better than me in this case. Honestly, I think you will find tons of YouTube videos about that. But I would prefer to think about this scenario as suppose we are all dinosaurs, right? And there is a there's a star falling, but not all animals go extinct. There are some, the extinction of dinosaurs, they gave opportunity to mammals, like that's us, right? So you survive, you adapt to the environment, and also some of the dinosaurs become today's birds, right? They are not completely gone; they just become birds. Like the birds are, you can see are actually the dinosaurs, like millions of years ago, like hundreds of millions of years ago. So I would say, like learning from this analogy, I would say you try to stay not fall behind too much about what's going on in AI, and try them and use them, and they're not that difficult as you think. So like I have a lot of skills that the skills.md, those files like I use daily to try to make my time more worthy. I find like it make my life really much more easier, and also it teach me one thing. It's like the effort you put into them, they are really not that important as the direction you want to go, because you want to choose like which approaches or what topic you are going to spend energy on, because before there were many like how to say collateral cost. Like you have to invest a lot of things, but now with AI, you can easily do a quick survey, like what is worth your time. So you want to use this ability wisely to decide the direction you are going into, right? So that's my personal experiences. Yeah, it's not that difficult to stay together with AI. Just don't panic with those fancy words like well, I can say this, but maybe some people disagree. I think everything here, they're just the prompt. They're just the prompt this way, that way, this way, that way. And they're organized in different ways. The skill is just a prompt, just a fixed, detailed, long prompt, and they're performing as following a specific organization, for example.
So if you were going to write a new program, say a Python program from scratch, and you wanted to use an agent to help you, which one would you choose?
Oh, so the question is, if I want to write a Python script from scratch, program from scratch, which agent would I choose?
Want to do your PhD thesis work. You write a Python program. It does all kinds of stuff. Simulation, data analysis, all that stuff. And you want to.
Honestly, okay. So
which one would you choose?
Today is February 17th, 2026. The go-to I would choose is cloud model, obvious like say 4.6. Yeah, that's the best model. People who are maybe watch this video later may think I'm making a mistake, so I need to state the date.
The date.
The date exactly. Yeah.
Might be different tomorrow.
Might be different tomorrow. Yes, yes, yes. It's changing so fast. But so far, I think the software engineer, as we know, is kind of down. Like it's kind of over. Like as we know in the past many years. So they are all doing perfectly fine. They are more behaving like super level, high level experts on writing codes. But what you do, what you choose to do, what background, what context you provide, they are no less important. They are even more important. Yeah.
So I've heard someone else give the same answer. So do you know what that answer is based on? Saying Claude is, but I think he was more specific about what the need is. So this is the context being research in health science or just general. Do you know what they're?
You mean the person's name?
No, I'm just saying why is Claude what your answer?
Oh, I don't know. I just feel like it feels more natural. It feels like more like a real person in sometimes, yeah.
Okay.
But the codex also works fine. Yeah, like in terms of getting things done, like ChatGPT codex also works fine. Yeah.
Yeah. I got a quick comment more than anything else. When I started using Claude, it had an attitude.
Yes.
Everyone seemed to learn me and we didn't get along now for lack of a better term. But
maybe it detected a little attitude out of you.
Yeah.
Trying to match with having personality in the program.
Yeah, I guess so. But yeah, I just thought that was weird that, the attitude went away or I understood what I was doing. That it seemed scary.
Yeah. Yeah, it's sometimes because those memories, like as we mentioned earlier, those memories they are persist somewhere, and it's getting better and better guessing what your true intention is. It's getting better and better. So you don't need to provide along the way, like you don't need to provide more context as you do at the beginning, right? Because it knows your preference. For example, let's say you hate writing text, which is bad habit, but Claude gradually will learn that and stop writing tests. So good thing and bad thing. Yeah.
Yeah. I noticed another thing about Claude that at times when I started writing documentation, I was getting really specific about what I wanted it to do, and then I realized, oh, it's doing it without me telling it to get that specific.
Yeah.
It just goes, this is a professional way to look at it.
Yeah.
And it actually writes it all out. So I am quite impressed right now.
Yeah.
Anyone online? Yeah.
Yeah, hi, Rongpeng. Yeah. Thank you so much for accepting my invitation, and I really appreciate this workshop. I feel super surprised because you actually put so many stuff in this a 90 minutes workshop, especially when you talk about skill and the open cloud. I was so surprised because it's really like a new concept and new knowledge. And thank you so much for this workshop. And I actually have something similar to others' question. So you mentioned you recommend the cloud code. Um, so are you talking about the the CLI you mentioned, or other interface, as you mentioned, like the IDE and what's the third one? Sorry, I don't remember. Yeah.
Just a GUI. So
Yeah, GUI. Yeah.
I won't suggest that, people to use the TUI, the terminal, the CLI. When I say cloud, I mean the model itself. The model itself. Whether you're accessing it from CLI, you're accessing from IDE or GUI, or even just calling it API, it's okay. So either way, it's okay. But I think overall, the model itself works better. Yeah.
I see. Okay. Yeah. So, which IDE do you recommend? I noticed that you actually opened several different software during this workshop. And what's your favorite tool? Yeah.
Okay. So
At this time moment, yeah, yeah.
So here's my go-to. I use anti-gravity to use up all its free cloud quota, so I cannot no longer use it for free. Then I switch to VS Code and use it's like a cloud OPS, the advanced model for critical tasks, especially to handling the first prompt, the opening prompt, because it does the best job handling the long opening, complex opening prompt. Then if I know I'm just going to do some simple work, for example, I ask the AI to run a test, or run a test, not to write a test, or just to push the code to GitHub, I'll just go for the auto. Like auto is just a 10% discount. So that's still something. Just, it's going to understand, okay, this is a simple request. I'm going to pick a, not so smart model to do that. Yeah. So I basically allocate my heavy job to the smartest intern. That's the idea. Yeah.
Cool. So for beginner, you recommend the anti-gravity because it's free for the first month, and then like maybe you can switch to other IDE like a VS Code, and in that IDE you can choose which agent you like which LLM you use, and so your strategy is to locate the heaviest task to like better model, right? Like just to give a summary. Okay, cool.
Yeah.
Thank you very much. Okay. All right.
One more question. So you mentioned early on that that for some of the large language models, it will forget the earlier prompts.
Yeah.
They'll drop off. But does that happen with Claude? That we set up a whole structure and then we do, 100 more things. Is it going to forget the early?
Thank you, Professor. This actually reminds me, like I kind of missed a good point. I think I should put it back into the text. So a key, how to say, takeaway, like I learned interacting with these models, is to try to persist the stuff frequently. So for example, if I did some important work, I would say summarize what we did, what we learned, and to a file named like project name dash date time .md file. So next time, if I realize it starts forgetting, I would drag that file back, tell it, oh, this is what we did, this like 30 minutes ago. Try to refresh your memory, do it explicitly. And I do this every time, for example, a big bug is fixed or a program runs successfully for the first time. So I keep doing that. So the answer to the question directly is that I haven't really encountered the issue, but I'm not sure whether it's because Cloud is good or I have this good practice. So I don't know, but I would suggest everybody do this good practice. So don't trust its intrinsic memory, like a blindly, although it's really good. Try to persist it, write it down, like write it on paper. It's like, write it on paper. Yeah.
Yeah, I'll verify that it forgets. And I told it, and when I get to specific points, remember what we did this last session. And it will summarize it and save it as a file.
Yeah.
I find that, remember what we did last session. Oh, okay.
Yeah, okay, yeah.
So you can read that file back in when you start the next session or something?
Well, I tell it to.
Yeah. Yeah.
Cool. Thank you.
Thank you.
No.
All right. Thank you so much. This is
Thank you.